Welcome, everybody. Dr. Adam here with you today. Today's lecture is Managing Varroa Effectively. And this is a lecture that I've created mainly because this is the number one pest you are going to be facing and the largest challenge for new beekeepers overall when they enter the beekeeping industry, mainly because this is really kind of a tough pest to understand. And because of all of the modes of action that we have available to us, miticides that we have available to us in the market, oftentimes the decision-making process can seem very overwhelming for new beekeepers. So the intention of this lecture is to bring you through kind of a brief update about the Varroa mite and then really get into the details of how we actually effectively manage this pest. So let's start with a little bit of review about Varroa in general. So number one, this is your top priority as a beekeeper, and this is an effort that is season long. This is not something that you start at the end of the season. This is something that starts in the very beginning of the season when you start keeping bees. So there is no time in the beekeeping season where you are not going to be focused on the management the monitoring and management of Varroa mite. This is your biggest thing that you will be doing as a beekeeper. Now, this has been a global pest. This is a global pest and has been in the United States since 1987, so since the mid-80s. And every colony in the United States has Varroa mites. If you happen to live on an island in the middle of nowhere and you have not imported any bees onto your island, maybe you don't have Varroa mite, but all of us have Varroa mite. The difference between people whose bees survive from year to year and those whose die from year to year is those who manage Varroa effectively can easily get their bees to survive. This is not a pest that we don't have the tools to work with. When this first came out in the 80s, this was absolutely devastating because we had no tools to deal with Varroa mite. We didn't really, everybody was just trying to get up to speed on how to deal with this pest. We have lots of tools that have been developed through research, and if used effectively, your bees can survive in the age of Varroa very well. So this is not something that is insurmountable. This is something you just need to spend a lot of time on and effort on to understand what are the best choices to make and how do I approach this as I'm going through my season. The big thing about Varroa mite and why it is so difficult for bees to identify in the colony is because it has this trait called chemical camouflage, which is the ability to touch things and take on the smells of them, those cuticular hydrocarbons, those smell molecules that are on the outsides of these organisms. So when Varroa mite is in a bee colony, it smells just like a bee. And so bees don't have any understanding that that is actually there. That is why this has become such a big problem for Apis mellifera, because it's not a co-evolved pest with Apis mellifera. It's co-evolved with Apis cerana and jumped species, we think, in the 1940s. But really, what this trait allows this bee to do is in colonies like European honeybees that are not co-evolved, they literally are in the colony and the bees have no clue they're even there. And so that is the biggest problem with this particular pest and why we as beekeepers have to take on so much responsibility to manage it. Now, this pest does feed on a couple of different things. It feeds on the fat body, which is a very important organ in adults. So this is when it's on adults in the phoretic stage, meaning the stage where it's moving around in the colony. The mites itself are feeding on the fat body of adults. When the honeybee is in its pre-pupal stage, going through pupation, that's when the mite actually feeds on the hemolymph. So that's the bee blood. So this is new research that's come out in 2024. We just got this research out, and so this is something that's new for all of us in the beekeeping industry, is this understanding that now we know that this mite is actually feeding both on the fat body and the hemolymph. And that's really important to understand because these are two different things. Fat body is an organ, whereas the hemolymph is actually the bee blood itself. Now, we know that it vectors over 20 different viruses, many of those very fatal to honeybees, lots of paralysis viruses. You see this picture down here at the bottom of a drone that has deformed wing virus that is vectored by Varroa mite. So these are things that are happening in your colony very readily, or these viruses are being passed around because of the feeding on the honeybees by Varroa mite. So, it's a passive vector for a lot of these viruses, which are detrimental to honeybee development. Now, just to illustrate where all of this is occurring on our honeybees, this is a research study from 2024 that looked at the feeding behaviors of Varroa mites on pupa. And so you can see in the pupal stage here that basically once that pupa starts developing, the mites are actually feeding on that second abdominal segment right there. And that's where they're feeding to basically take in to take in hemolymph while they are while the bees are going through that metamorphosis process. You can see that the two red dots here indicate that over 85% of the time in this study, that is where they found the mites actually feeding on the pupa. So that is when it's feeding on the hemolymph. Conversely, when it's feeding on adults, we also know that it is on those abdominal segments where we primarily find them. So here in this study, this is Sam Ramsey's study from 2019, you can see that where the red dot is here on the left lateral view and where the green dot is on the right lateral view are basically about 80% of the time, that's where your mites are going to be on your adult bees. And you can see in this picture down below, the mite is tucked right underneath that abdominal segment. This is why we don't see Varroa mites in colonies. Number one, they're reproducing in capped cells, so you're not going to see that happening. But number two, when they are on adult bees, they're typically underneath these abdominal segments tucked away, so they're difficult to see. If you're seeing Varroa mites walking around on your frames and walking around on your bees, they are likely at explosive levels at that point. Typically, when mites are just in colonies, it's very rare that you're actually going to lay eyes on them without doing some sort of a monitoring test that we're going to be talking about here in a bit, the sugar roll or the alcohol wash. So you just need to understand that where these mites are located on adult bees, you're not going to see them. So it's really important that the monitoring becomes the way that we actually establish how many mites we have per number of bees. Now, when it's on the adult, it feeds on the fat body. And we talked about that a little earlier. Now, the fat body is a really important organ when it comes to honeybees. Fat bodies are throughout the body. And so when fat bodies actually when they are putting on stores, you're having these fat body stores that are occurring in the abdomen, the thorax, and in the head as well. So they're throughout the body. But these fat bodies are responsible for a lot of different things. One big thing is storage. And so, we think about fat storage in the context of things like winter. When you're going to say like you're a bear and you're putting on all of this weight to make it through a long hibernation of winter, you've got to have those fat stores. If you can't put fat stores on, you're a skinny bear going into winter, you're going to starve through the winter. And it's the same thing with bees. We see this picture here to the right. The abdominal segment that you see, or the abdominal section that you see here on the right, is full of fat stores, where the one you see on the left is absent of fat stores. And those bees need those fat stores when they're winter bees in particular, because of those long periods of time that they have to go without having ready access to, lots of resources out in the landscape. The other thing, aside from just storage, that this fat body does is it is also responsible for protein biosynthesis. And this is really important because the compound that it develops is one of the compounds that it's responsible for synthesizing is vitellogenin. Vitellogenin is a glycolipid protein, and so what that means basically is that it has a whole bunch of stuff in it, like fats, it's got protein, it's got sugar in it. It's a super rich compound. The best way to describe vitellogenin to new beekeepers, aside from just this, amazing rich compound, is that it is really responsible for kind of longevity in honeybees. And a lot of, times I've heard vitellogenin talked about as like the fountain of youth, basically. And basically what vitellogenin is correlated with is that bees that have high levels of vitellogenin live much longer. So for an example, your queen always has a very high vitellogenin level. She can live for years. Your workers, when they are nurse bees, when they're in the colony, when they are nurse bees, those workers have extremely high vitellogenin levels. The moment they switch over to forager role, the vitellogenin levels drop and they live for about 2 weeks. So vitellogenin is the longevity compound. And if you think about it in the context of winter bees that have to get you through several months of winter, vitellogenin, if your fat body is compromised and bees cannot put on lots of vitellogenin, can't synthesize lots of vitellogenin, they will not live very long. And so many times, and this is kind of a rough rule, often I will say that if your bees do not survive past January 1st, when we're talking about going through winter, it is usually a key indication that your varroa mite levels were out of control because your winter bees literally could not put on fat stores, could not put on vitellogenin, the longevity compound. And so that's why your bees die early in the season when they're compromised by varroa mite. Usually, if they live longer than that, say past the first of the year or past the 1st of February, most of the time, if you're seeing dead outs, it's due to something else. It's due to like starvation or moisture or something like that. But early season death of colonies going into the winter is almost always a key indicator that your mite levels were out of control and literally your winter bees could not put on vitellogenin in quantities enough to live long enough to actually be able to get you through winter. So mites have a very huge impact, not just on viruses, but also on your winter bees' ability to actually survive winter. So a healthy fat body is the absolute key to winter bee production and survival. And depending on where you're at in the United States, winter bee production starts at different times. Winter bees are going to come on well before winter starts. For me, here in the Upper Peninsula of Michigan, we start to see winter bees coming on at the end of August. So if our mite levels are not under control in August, our winter bees are being affected by mites, and then I expect them to be able to make it through the winter, which is just not going to happen. So it is really critical that your bees have low levels of mites all season long, especially at the end of the season when your winter bees are being put on. And oftentimes people don't think about winter bees being put on early. Your winter bees are put on much earlier than winter starts. So if you're thinking, oh, well, I'm just going to take care of it in the fall, I'll do a mite treatment in the fall and they'll be fine. No, because by the time you do that, your winter bees have already been raised. You're not doing anything to help those bees that have already been compromised by varroa mite for weeks. Season-long effort, varroa mite management. All right, let's talk about the life cycle. All right, the phoretic stage. So the phoretic stage is when the mites are moving around on adult bees. So that's happening on adult bees. Now the phoretic stage can last for, days, but up to 2 months. And when you're talking about winter, these mites will actually overwinter with your bees. So if your mites are still out of control or at even high levels, those mites are still overwintering with your bees. They're not reproducing during the winter, but they will overwinter with your bees. And those will be the ones that are feeding on the fat body. In the reproductive stage of mites, which is the stage that is inside of the cells, that's happening with bees and capped cells. That's when they're feeding on the hemolymph on that pupa. And that whole life cycle for these mites from egg all the way to adult is 10 days. So it's a very fast process that these mites are reproducing. Here's a graphic representation of all of this happening between drones and workers. Now, when it comes to drones, mites have been shown to be 10 to 12 times more likely to lay eggs in a drone over a worker cell. And the reason is because the drone life cycle is longer. It's 24 days instead of 21 days. And so they have a few extra days to reproduce. So, and to put that in context, like when you're thinking about drones and the reproduction cycle, 10 days is the reproduction cycle, right? Your workers are capped for 11 days, your drones are capped for 15 days. So that's how quickly this is happening. Now, mites do not reproduce in queen cells. And the reason is because royal jelly has been shown to actually be a repellent for mites. But in addition, the queen is only in a capped stage for 7 days. And so it's not long enough to actually fulfill the full reproductive cycle. So that's something just to keep in mind. When we look at the graphic representation, what you can see here is that right before the cells are capped, your mite's going to drop in and then bury itself underneath the larva in there. And let's just take a look at the drone one because both of them are pretty similar. The big difference between drones and workers is you're just going to get more mites out of the drones because there's a longer period. But let's just take a look at how this all happens. The first thing that mite is going to do, and the mite that's dropping into the cell is a mated queen, mated female, meaning that she can lay eggs right away. So she drops into the cell. After a couple days, she's going to lay a male egg. That male is going to hatch, and then you have female eggs that are being laid as well. The mites go through 2 immature stages before they turn into an adult. Once they are adults, your male's going to turn as an adult first, and then your females. they all mate. And so the brother mates with his sisters, and then it is the sisters that come out of the cell. So generally, for just kind of for a general fact, for every one mite that goes in, you generally are going to get 2 to 3 that are going to come out that are mated females ready to do this all over again. So this is an exponential rate that these things take off. You would be shocked, and this is why monitoring is so important. In between, say, 8 weeks, if you were to not monitor for 8 weeks at the height of the season, this can get away from you very, very fast. So this is something that you need to be constantly on top of because of this exponential growth rate. The other thing that you need to understand is the population dynamics as well. So in addition to having these rapid life cycles and these huge growth rates because of this exponential growth that we see in mites, we also have a thing that is this parasite lag. So in host-parasite relationships, you always will see the host population needs to be peaking before the parasite peaks because the parasite relies on the host to reproduce. Without lots of hosts, the parasite can't really do much. And so this is through evolution, this is how these relationships work. So what we see in this graph right here is you see bee population is the blue line and mite population is the orange line. You see that the y-axis is our population size and the x-axis is our phase. You can think of that as the time of the year. So what we see is that we come out of winter and through winter in this dormant phase. Once we come out of the dormant phase, your bees are going to start doing this population increase. This is spring buildup. Bees rapidly increase in the spring. So you see this huge, huge curve right here, this deep slope right there. And then our population peaks, usually around mid-season. For me up here in the north, usually we start to see our population peak right around the middle of July. Once we hit August in my area, and this is going to be different for everybody depending on where you're at, but once you get past that population peak, as soon as our colony starts to condense down, that's when your mites are going to peak. This coincides with winter bee production because that peak, that summer peak, when we start to see hives start to condense, that is the first indication that hives are starting to prepare for winter. This also is going to coincide with winter bees starting to be produced. So as soon as that starts happening is when your mites peak. So typically your mites are peaking right when your winter bees are being put on. This is why it's so hard to get colonies to survive if mites have not been taken care of all season long. You're trying to avoid this peak. That's why we do all of the management that we do with Varroa mite, because you don't want this to happen. You're trying to avoid this. You're trying to put all the preventative measures in place so that this does not happen at a huge rate. And let me tell you, having worked in this industry for so long and working with beekeepers all over the world, when this gets out of control, you will see mite counts that will blow your mind. I'm saying like 54 mites per 300 bees. Huge numbers. So this is why this whole idea of season-long management is so important. The bees are being fed on by these mites. They're being passed viruses when they're being fed upon. They're also having really important things compromised so that they can't actually do the things that they need to do biologically to make it through a cold part of the year or a long period without food. And then you have these population dynamics that just work against you. That if you aren't doing anything, the mites explode at the exact time you need your bees to be healthy. It is a very tough situation to be in, and this is what makes or breaks beekeepers nowadays, is being able to understand all of this and put it together so that you can make logical decisions when you get faced with issues with Varroa mite. Now, you may be asking yourself, where are these damn things coming from, right? These mites are just too much. Where are they coming from? Well, they're coming from all sorts of places. First, they're coming from feral colonies. We know from research that feral colonies, meaning wild colonies, And keep in mind, European honeybees are not native to North America. So when we say wild, we are not talking about native colonies. We are talking about feral colonies that have escaped management. Feral colonies have a 20% survival rate because of varroa mites. So devastating to feral colonies. In addition, those feral colonies are reservoirs for varroa mites as well that can interact with your bees in the landscape and pass varroa mites off to them. Your neighbors are also a huge reservoir for varroa mites. If you live in an area, especially an urban area where there's lots of beekeepers, or maybe if it's in a rural area where you just have a ton of saturation, if you have somebody that's not managing mites around you or not doing a very good job of it, that can very well become your problem. And we often see this in the fall with absconding hives. With varroa mites, lots of times the mite pressure gets so high that the whole colony just leaves. And what they do is they'll join another colony and bring all their mites in tow. We call this a Varroa bomb. And this is very common in areas where there are lots of bees being managed by many different people. When we had an operation in Lansing, Michigan, several years ago on an urban farm that we had, we did have this happen one year where we had a guy that we knew that was local, that was a treatment-free beekeeper and had a whole hands-off approach to varroa mite because the bees can just figure it out themselves, which is not the case. And we ended up having a colony that we had had for, I think it was 7 or 8 years, that was killed by a varroa bomb. And we knew exactly what our varroa concentration was because we keep very good notes and do monitoring all the time. So I knew what my mite counts were going into winter. And this happened in the fall. And it just so happened that by the end of November, that hive was dead. And when I did an autopsy on it, it was completely full of varroa mites. So this can become your problem if your neighbors are not doing a good job of management. It's why you have to be on your game all the time when it comes to varroa. The landscape itself, there's been research that's shown that when bees are foraging that have varroa mites on them, the mites will jump off, hang out on the flower, and wait for another bee to come by. So if you're in the same landscape, even as other beekeepers, this can be passed off to you. Nukes and packages. Nukes are definitely going to have mites in them. There's no way that you're going to get around that. They should be at a managed level, so below the thresholds that we'll be talking about here in a bit. But they are going to invariably bring pests and pathogens potentially with them. Nukes are going to have more because they have brood, but packages are very well could be carrying phoretic mites with them as well. Mites are in all colonies in the United States, so it's not like you're going to get away from this. This is just part of the reality of beekeeping nowadays. Migratory operations, although I understand the value of migratory operations and have a lot of friends who are migratory beekeepers, there has to be the understanding that these migratory operations move around the United States constantly during the season, and they bring all of their pests and pathogens in tow and redistribute those pests and pathogens all across the United States every single year. It's just the reality of the system that we have in place in the United States. So even if you're in an area where you think you're going to get it under control and you think you have full control on it, it's just going to take one migratory operation, drop it off bees in your area for a bloom, and boom, you've got a reinfestation of these things again. So that's just the reality. There's no blame that we're going to lay on anybody for something like that. That's just the reality of the system that we have when it comes to migratory operations and the pollination that our nation needs desperately in the agricultural sector. So this migratory beekeeping plays a very important role in our agricultural systems. And, one of the realities of that type of a system is just redistribution of these pests and pathogens. Something to think about. All right, so let's get into the nitty gritty of managing varroa mites effectively. All right, so the first thing that we need to talk about is integrated pest management. What we are going to be talking about in the rest of this lecture is based in the theory of integrated pest management. IPM is the acronym for this. And this is a sustainable science-based decision-making process that combines biological, cultural, physical, and chemical tools to identify, manage, and reduce risk from pests and pest management tools and strategies in a way that minimizes overall economic, health, and environmental risks. The short version of this is a tool that we use. It basically, IPM gives us a set of tools that we use in a order to strategically address these pest issues in a sustainable way that is safe for us and the environment. Are things to always think about when it comes to pest management, because it's a big part of the EPA registration process for products that we use. But the idea here is that we don't start with the harshest thing. We start with many different tools. So we combine these biological, cultural, and physical methods, strategies to deal with pests well before we use chemical tools. But these are all tools in our toolbox. Let's take a look at how this plays out. This is the integrated pest management triangle for managing Varroa mite. This triangle is what we use in IPM, regardless if it's Varroa mite or if you're applying this to an agricultural system, like maybe corn management or something like that, and you're trying to deal with a corn pest. The same idea applies here. But I'm going to walk you through this triangle. So when we're talking about the IPM triangle, what we're talking about is starting at the bottom and working our way up. And the methods that we use at the bottom of the triangle, underneath the red line you see here, are preventative measures. So we do these as good beekeepers to set ourselves up for success well before we ever even know that we have Varroa mite. These are things that we just do as good managers. The hope here is that by doing these preventative measures, we may never get to the point where we actually need to do a chemical intervention. And that is ideal, because we only use miticides when we absolutely have to. You do not use miticides prophylactically. You only use them when absolutely needed. And that should be true for every time you use a chemical in agriculture, is you only use it if absolutely needed. You don't do this preemptively. That's not a good way to use chemistries in agriculture. And by using chemicals exclusively, that's how we get resistance. That's how Varroa mites develop resistance to these chemistries. So it's our responsibility as managers to make sure that we're doing the preventative measures so that when we do need those chemistries, they actually work for us. But if we're just using them all the time, the likelihood is over time, Varroa mite's going to develop resistance to those products, and they're going to become useless to us. So this is a really important part about being a good beekeeper, is understanding that you're not just throwing chemicals at problems. You're always starting with prevention first. So let's start with this down at the bottom here. So cultural controls. Cultural controls can be thought of as what you're trying to do to reduce reproduction overall of the mite we're talking about. So one of the ways that we can do that as a cultural mechanism, something that we just do as good beekeepers, is select resistant stock. What I mean by resistant stock is queens that are bred specifically for Varroa mites. And we'll talk about some of those queens here in the preceding slides. But getting a queen that is selected for Varroa mite hygienic behavior is giving your bees a leg up without having to even do anything, right? You're just giving good genetics. And that's really important. So starting with good genetics should always be your first point. And if you're combating Varroa mite, which you all are, those should be genetics that have been selected for Varroa hygienic behavior. The next thing that you can do as a cultural control is a brood break. And that's simply where you're caging up the queen, or you're doing a split and letting them raise a new queen and giving them a break from the brood cycle, because mites reproduce in brood. It's things you can do without ever even doing a Varroa mite monitoring test. Mechanical controls. These are things like mite trapping. So drone brood frames would be a great example of this. Screen bottom boards. Screen bottom boards, when they first came out, we were told that they were going to be like the solution for Varroa, and this has been probably 15 years ago, maybe even more. I'm dating myself now. But really what we found is that over time, they do provide some level of management, but it's very low. What the research shows is that less than 20% of the population of mites will actually fall through those screens. So although it is one of many things we can employ, again, it's not just a one and done type thing, and none of these things are. These are all additive effects that we have here by putting these all together. So I'm not saying that you're going to do one of these. I'm saying you may do all of these, all right? It's not like you're selecting each one of these. You're going to select resistant stock. You're going to do a brood break. You're going to do mite trapping. You may decide to do screen bottom boards. Those are all additive effects to help prevent the overwhelming number of mites being reproduced in the colony. Now, those two control methods, the mechanical and the cultural controls, those are just what we do. You've never touched a chemical to this point. You've never put a mite strip on at this point. And you may get good control using just those methods right there. And that would be fantastic, because if we don't have to use the chemicals, we don't want to. But invariably, at some point, you are going to hit what we call an action threshold. And we'll talk about what those thresholds are here in just a bit for you as a beekeeper when it comes to mites. But these action thresholds that we have tell us that when we're above this many mites per so many bees, and we use a 300 bee sample in the methods I'm going to show you, when we have so many mites per 300 bees, we have to do something. And that's been developed, those thresholds have been developed through research. So you can also think of it like this. If you don't do something when you hit that action threshold, your bees are going to suffer because of it. Past that point, they're just going to suffer. It's going to cause all sorts of problems for you. So you always want to stay under the threshold. That's the goal. That's why we have it established. But if you get over that threshold through your mite monitoring, that is the only time that you are going to use a chemical intervention. There's no other time that you're going to do that. Well, the only other time you may do that, and I'll back that up just a second, the only time you may do this without a mite count to justify using a chemical is in fall with an oxalic acid treatment. Because many of us, and myself included, will do a cleanup treatment after brood comes off completely. But at that point, you can't do a mite check because there's no brood to check mites on. So you just do it because it's a cleanup treatment. So that would be the only time that you're going to use a potential chemical without justification from a mite count. The reason we use the cleanup treatment is because you do not want any mites on your winter bees as they're going through winter. And so we use that as the final treatment. Plus, it helps with eliminating mites when we get into spring buildup as well, because we lower the number of mites that are going through winter with our winter bees. But when you get into those chemical compounds, there's going to be two categories that you're going to be able to select from. There's going to be what we call soft chemicals and hard chemicals. And you're always going to start with the soft chemicals. You're never going to start with the hard chemicals. The soft chemicals are naturally derived compounds. These are things like thymol, like Apiguard, Apilife Var, formic acid, like Formic Pro and Mitaway Quick Strips, or oxalic acid, or Hopguard, which is hop beta acids. Those are your naturally derived compounds. The synthetically derived compound that we have on the market, and the only one I'm going to be talking about for this particular lecture, is Amitraz, which is Apivar. Or Amiflex. I think there's a new product called Amiflex as well. But that's Amitraz. That is the hardest chemical we have on the market. And it is going to be the very last thing that you would use if you are using a chemical intervention. I have never in my career had to use Amitraz. The other chemicals work just fine if they're used appropriately. And that's one of the biggest things we'll talk about when we get into those chemical interventions is how inappropriately those are being used, how wrong people are in the way they are actually using these chemistries because they're not reading the labels. We'll talk about that here in just a moment. But first, let's back it up to our base of our IPM triangle, our cultural control. So now we're going to go through each one of these steps of the triangle and talk about in detail what these management practices are that you should be implementing in your apiary. So the very first one is hygienic behaviors, that resistant stock, right? So bees, after Varroa mite was introduced in the United States, a lot of breeding efforts started coming into play and are still happening today, specifically to basically breed European honeybees so that they are resistant to Varroa mite, meaning that they have behaviors that allow them to deal with it. And we call these Varroa sensitive hygienic behaviors. VSH is the acronym that we use for this. VSH is really a behavior that involves a lot of different things. And I'll talk about it here in just a little bit in the next slide. But really what you need to be thinking about is grooming is one of the main behaviors where you groom yourself and your friends and you're able to detect, uncap, and remove diseased larvae and pupa. Russian honeybees are a really neat example of this because inherently, and we think this is because of the geographic proximity to Apis cerana, the native host of Varroa. We kind of think that there may have been some interaction with Russian honeybees and Varroa early on in the evolution of the Russian honeybee. And so the Russian honeybees actually have the ability to detect, uncap, and remove Varroa mite inherently in their gene line. And we'll talk about how that impacted our own U.S. agricultural system by USDA bringing in Russian bees and doing a breeding effort with that. Now, when it comes to the hygienic behaviors of VSH, this is a graphic representation of what's happening. So what you see is You have mites that drop into the cell right before it's capped. Once it's capped, they start feeding on the prepupal and pupal stages, and then you have that whole like mating cycle that we talked about, where you have males that are hatched first, then they mate with their sisters, and then the gravid or mated females are the ones that come out with the mites. When you have a VSHB, they have the ability to recognize those cells that are compromised by varroa mites. So when we've talked about chemical camouflage in the past, what I've been telling you is that whenever they touch, they take on the smells. But there are very, very, very small nuanced differences between the smell of a varroa mite and a bee, even when a mite's in a bee colony. Those nuanced differences are what these VSHBs can actually detect. The regular Italians and non-VSH bred bees don't have the ability to detect those nuanced smell differences. So that's one of the major things, is this ability to recognize that there is actually a problem. And remember, most European colonies, European honeybee colonies, they can't detect that there's a problem. So this is a big thing, this idea of recognition. They can recognize those problems, and then they will go and uncap the cells that have been compromised by those mites, remove the diseased pupa, prepupa, or pupa, and get rid of it. They also have these grooming behaviors. And so one of the big things that you want in a bee that can take care of mites is one that's constantly cleaning itself and its friends. These mites are on they're ectoparasites. They're on the outside of the bee. And so if you're constantly grooming yourself, the likelihood is that when mites are on you, you're going to be interacting with them and potentially can get them off. Some of these bees also have the ability, once they're grooming, they will actually grab onto these mites and chew them and kill them as well. So these are some of the qualities that we're looking for when people are breeding for these VSH behaviors. This is what you want. These are the resistant stock that I was talking about. These are the queens you want, are queens that are selected for these specific behaviors. These aren't your average Italians. These are special bees. And you may pay for one of these queens that we're going to be talking about. You may pay, a premium. Myself, our company, Beewise Farms, we sell VSH queens that we work with a breeder in California who we import them here into Michigan. And those bees are selected specifically for that criteria. We charge $42 a queen for those bees. So you are going to pay a premium for your queens that will have these behavioral characteristics. It is worth every penny when those colonies survive year to year. So setting yourself up for success is really important part of integrated pest management. This is number one preventative measure, is these cultural controls. All right, let's talk about some of the VSH queens that are available to this. This is very brief, and these are not all of the lines that are available in the United States. There are lots of VSH lines available in the United States. The first one I want to talk about is the University of Minnesota's Minnesota Hygienic line. This is a line that started in 1993 with Marla Spivak. Marla has been one of the pioneers in breeding for Varroa resistance in the United States. She's a MacArthur Genius Fellow, an amazing entomologist. And her work at the University of Minnesota has been key in developing mite resistance in bees. The line that they have developed over the years, and they're still working on this project. This is not you don't just stop with this. This is an ongoing thing. But basically, one of the things that they've seen from some of their studies is that this line of bees can control mites for up to a year before you actually need a treatment. So that's a pretty big deal, right? I mean, if they can take care of those mites, you're still going to be monitoring the entire season long, regardless of what kind of queen you have. But if you're seeing that mite levels, are sticking at a very low level all season long, why would you use a chemical to intervene with this? The bees have literally been bred to take care of this. They can handle it if they're showing you that they can, and that's through your monitoring. These queens are widely available throughout the United States, so one line to think about. One of my favorite two lines of Varroa-sensitive hygienic bees is pole lines. Pole lines were part of a USDA breeding program. This is at the Baton Rouge facility in Louisiana that this has been happening. And you can find these queens available all throughout the United States. But pole lines were specifically selected as VSH bees. They work very well on VSH colonies. My mentor actually from California was a queen breeder. That's where I cut my teeth, and he was a pole line breeder, and so I'm very familiar with these lines. These lines do very well in all climates. I have used them in California. I have used them in the Upper Peninsula of Michigan. They are fantastic queens. I really like these queens. And in fact, every few years, we bring more of these queens into our apiary just for genetic diversity. And I just really like the queens. So they're fantastic queens as well. But a USDA breeding program that has developed those as well. The last one that I'm going to mention here, and again, this is a very short list. There's lots of different lines of bees that are VSH selected, and some that are, people are doing on their own, right? That are not these like, designer breeder lines, but somebody that may be doing a, really good job of selection, that has a small queen breeding operation, that's doing a really good job of selection on VSH. You may be able to get some really stellar queens from someone just in your local area. But always make sure when you're doing this that you're talking to them about what selection process they're using. Like, are they using a Harbo assay? Are they using a liquid nitrogen assay? These are questions that are a little more advanced, but these are things that you would want to know if it is a kind of a, hobbyist that's doing this on the side. But these breeders that are doing this large time, they are very focused on making sure that they're giving their customers quality products. The Russian honeybees are another one. So this, when mites came into the United States and we started seeing this research showing that Russian honeybees had this ability to deal with mites very well, USDA brought in Russian bees into the United States and started doing research. This happened in 1997, and this is an ongoing process. And there's actually an organization that was developed that works hand in hand with USDA and Russian honeybee breeders, the Russian Honeybee Breeders Association. It's actually an organization that we've done some work with as well. Russian honeybees are very interesting honeybees, and I'll tell you a few things about Russians. And I'm learning more about Russians every single day, mainly because of the work that we're doing with these breeders. What I will tell you, and what the data I have seen from these bees, the ARS facility in Louisiana has data showing that some of the colonies that they have been managing with Varroa mites, with Russian honeybees, have kept Varroa mites under threshold for up to 7 years. They've got colonies they literally have not treated in 7 years that are Russian honeybees. Now, the big problem with Russians is that you will have a lot of people who will say that they are selling Russians, but I'm going to tell you there's only about a dozen Russian honeybee breeders in the United States right now. So it's a very small group of individuals. So these are not as widely available as some of the other queens that you can get. And in fact, many of the breeders who we work with and who I know, actually most of their queens are being sold with their own nukes. So you may have to work to find somebody, but don't just take it for face value that someone's selling Russian bees, because it is a very strategic and strict breeding program that they are engaged in. The protocols that the Russian honeybee breeders have are done through the Breeders Association. So these are very, very intensively tracked bees in this breeding program. They're still doing selection and all of that great stuff on these bees, but Russian honeybees are great bees. Now, the thing that has been over the years that they've gotten kind of a bad rap for in the industry is this idea of aggression. Most of the breeders that I know will say that the bees are no aggressive than any other bee. And that's been my experience as well, is that I think it's more that there's kind of this misconception about them. There are some unique qualities of Russian honeybees that are different than most of the lines that we work with. They have delayed buildup, so they don't normally start building up in the spring until resources are available. So oftentimes that's a very delayed buildup than most of us are used to, especially those of us that, do nukes and packages and things like that. Most of our lines were used to like really rapid buildup in the beginning of the spring, and oftentimes we augment that with food, supplemental food. These Russians typically highly delay their brood production until there are just tons of resources in the landscape, and then they just explode. So there's nuanced differences between all of these lines, and every line of bee you're going to work with, every like whether it's a Russian or a pole line or a Purdue ankle biter or whatever it is, they're all going to have nuanced management differences. And so one of the things I do say to a lot of my students early on is, your first couple years, don't get too hung up on this. Management's going to be really key. But as you get moving on into your career and are able to kind of determine what these nuanced differences are between lines, because you're going to have to notice these as they're happening, that's when you really want to start getting into this type of thing. But I would say, no matter who you are, starting with good genetics is a good thing. But your ability to be able to recognize these differences is probably going to take a few years before you're to that level if you're brand new to beekeeping. But this is what you've got, and these are all cultural controls, right? We haven't done any used any pesticides whatsoever at this point. The next cultural control that we talked about is brood breaks. This is a really good thing to incorporate into your apiary, and doesn't it's not really any problem for anybody. It's just a break in the brood cycle, which allows your bees to kind of recover and not allow mites to reproduce. So this could be done in a couple different ways. Brood breaks could be something as simple as doing a split and letting them raise a new queen. It takes about 4 to 5 weeks for a new queen to be raised. During that period, you're going to go broodless, so there's no ability for those mites to reproduce once you hit that broodless phase because everything's hatched out at that point. So you're giving your bees a break through that split. That is one of the easiest ways you can incorporate a brood break into any apiary, is by doing a walk-away split where you don't introduce a mated queen. You just let them raise their own queen. Easy peasy. Requeening is another one. So if you've got a queen, say that is causing some problems, you can requeen that colony. You can take out that queen and you can let it go for a little while and raise a new queen, or you can introduce, can go let it go for a little while and excuse me, and then introduce a mated queen. But the idea here with these brood breaks is you're trying to break the brood cycle. You're trying to give them a break from raising brood so that all these mites can hatch out, and then there's this break in their ability to reproduce because there's no brood. Caging queens is another thing that people do, and this is a great activity if you don't want to lose your queen, like if you're not interested in requeening or doing a walk-away split where you're not introducing a mated queen. Caging your queens is a great way to do this as well. This is a practice that's done all over the globe. I've seen this incorporated in most all the countries that I've traveled to and done beekeeping with. Caging queens, depending on the resource that you're looking for, the scientific literature's kind of got a kind of range on what you would use how long you would cage a queen for. Depending on the resource that you're looking at, here in the United States, some of the resources, are saying like 16 days, 2 weeks basically, and that's long enough for all of that capped brood to hatch out, a 16-day period. But when you look at European journals and a lot of the recommendations from European beekeepers, it's up to 24 days. So, this is something it's not a hard and fast thing, but, it's something that you want to look at in 16 to 24 days. You're going to be just fine by caging a queen in that situation. The idea here, again, is that you're caging her up so that we're not getting more brood on and that we're giving our colony a break from the brood to interrupt that brood cycle, or excuse me, that reproduction cycle of the mite. Now let's move into mechanical controls. So the mechanical controls that we mentioned the screen bottom board. I'm not a big advocate of the screen bottom board because it's less than 20% of what your mites are going to actually get down into that screen and not be able to come up. They're more expensive, and so when you're in a bigger operation, spending extra money on those bottom boards, it's just more. So I actually have maybe about a dozen screen bottom boards out of about 100 colonies, so not a whole lot of them. And those are artifacts from when we were being told that this was going to solve all of our problems, 15, 20 years ago. What the main mechanical control I want you to really focus on is drone comb removal. And the reason that drone comb removal is so important is because we know from research that mites will reproduce in drone comb 10 to 12 times, or they're 10 to 12 times more likely to reproduce in drone comb than worker comb. The reason is they've got extra days for reproduction. So it's a longer period for them to be in that secured place to be able to reproduce. So we use many different methods in order to remove drone comb, and I'm going to give you a few examples here. So one of the first ones that you'll see are these green frames. These are something that you can buy from beekeeping supply companies all across the United States, but these are frames that have the impression on the foundation that's the size of a drone cell. Drone cells are slightly larger than worker cells, and so these specifically are made for drones. So all they'll put on these frames is drone comb. With the green frames, once it's filled out and capped, you take that frame, throw it in the freezer, kill everything, and then scrape it clean and start all over again. Or you can take it out. What I like to do, I like to take it out once it's all capped and give it to my chickens and let them clean it up. nutrient rich food for those chickens. But you're getting rid of it at that point. So you've got all of the mites trapped in those cells at that point. When they're capped, you take that out, freeze it, kill them, and you start all over again. Really great way to manage mites. And this is something that you can do all season long. So you can always be every inspection, you could be removing this drone comb frame and cleaning out a huge selection of your mites. Another thing you can do is that oftentimes over time, like you see in this bottom left picture, you will have frames that will just have a lot of drone comb on them. This is an example of a wax foundation frame. So wax foundation, oftentimes when wax foundation ages, especially if it's not cross-wired, it will get wavy. And so you'll get these frames that have high and low spots. The high spots are going to be where the drone comb is put on, because when you get those high spots, it basically stretches the cell open a little bit. And so they end up becoming drone cells. If you have frames that look like this in your colony, get them out of there. Don't leave them in there. This is a drone frame, and all you're going to have in here is mites and drones are the only thing that are going to come out of this. So that's another method that you can use when you come across frames that look like that. Just get rid of them. In this situation, when I have frames like this, I let the chickens eat them out, and then I go ahead and burn the frame, because I don't need drone comb frames when it comes to when it comes to the wax foundation. That's usually like the last stages of that frame. Another method is that you can also use something like this method right here. This is a method that I actually was exposed to in Slovenia when I was traveling there working with beekeepers. And this is a frame from an Aja hive, or an AZ hive, for those of you who are not familiar with that term. This is a hive that we work from the back instead of like a Langstroth hive that we work from the top. But essentially what beekeepers in Slovenia are doing is they divide their frames. This is a deep frame, a little bit different size than what we have in the United States, but the same general size, a deep frame. They divide it into 3 sections, and then basically every time they come into here and one of these is capped, they remove it. And so you constantly have this cycle of removal in these frames, and they leave these frames in all the time. And so you're just constantly removing drone comb. Great, great method for removing mites. All right, so that is something to think about. This is something that you should just be doing. Again, the mechanical control. So we have never, to this point, we have not touched a chemical, right? No chemicals have been touched whatsoever, and these are very good mite management strategies up until this point. No chemicals whatsoever. You may not have to do anything beyond this. You've got well-selected bees and you're doing all of these preventative measures. You may actually never get to those high levels of mites because of these methods. The likelihood is every once in a while you will, because they're just so voracious when it comes to those mites. So let's talk about mite monitoring. This is something that you are going to be doing all season long. It's going to start when you first start working your bees in the spring, and it's going to end in the very last cycle of working your bees in the fall or winter, depending on where you're at in the country. You want to be doing mite monitoring, though, on days where there is good weather, because you are going to be getting into the colony and taking out frames, taking samples of bees, all of that good stuff. So it needs to be daytime highs, need to be in the 60s. You don't want to see nighttime lows going into the freezing temperatures at that point either, because those bees are, if they does go to low temperatures, they're going to be clustering up really hard. But even at 65 degrees, your bees may be clustered. But that's kind of the safe spot, is if you want to have those daytime highs kind of higher and nighttime lows that are not freezing. This is done at every inspection. So I recommend every 3 weeks, but 3 to 4 weeks works. But the more often you do this, the more on top of these mite numbers you're going to be. So it is important that you recognize that this is just something that you're going to be doing all season long. Okay, it's just part of your regular management activities at this point, is mite monitoring. So how do we do this? Well, you're going to first have to decide which method you want to use. Now, I have 2 methods listed here, and there are more methods than that you can look up and find stuff out about, and even buy trinkets that help you do tests. The CO2 method is something that's come out in recent years. It has been shown to be about as effective as the sugar roll. The ether wash is something that we used very early on, not really used much any longer. The 2 methods that are really preferred are the alcohol wash and the sugar roll, and I'm going to make it even easier for you. The alcohol wash is the method you want to be using. And the reason we want to use the alcohol wash over the sugar roll is the sugar roll has a lot of factors that come into play to make sure that it's done right. So I'll talk about that after we talk about the alcohol wash. But I want to impress upon you that it is imperative that when you do these monitoring methods, the count that you get is accurate. If the count is not accurate, and say, for example, you do a test and you show that you only had one mite per 300 bees, but in actuality, you have 25 per 300 bees. When you miss those things, it's your bees who suffer. And high mite counts will kill a colony. It's over time, but if you try to get it through the winter and you've had mites that are that high and you've been thinking you've got low numbers, that's when disaster strikes. So you need to be doing this right, and you want to make sure that you have the absolute most accurate method. And that's the alcohol wash. Now, the difference between the two here is that the bees, when you do an alcohol wash, you are going to kill 300 bees. And nobody likes that. Nobody likes that. When I do alcohol washes, I give gratitude to my bees. Every single alcohol wash I do, I thank them for their life and what their sacrifice is. But these bees are altruistic. The superorganism is what matters at large for the colony. So these bees sacrificing their lives to save 50,000 or 60,000 of their kin is what bees do. That's part of their life history. They are altruistic. It's always about the superorganism. So even though we may feel bad that we're killing them, this is something that they would do on their own to save a colony. Say if they were being attacked by the bear that is hitting that colony and destroying it, those 300 bees that you're sacrificing, they'd be on that bear in a heartbeat, sacrificing their life to save the colony. It's the same thing with mites. Think about it as these bees sacrificing themselves for the livelihood of this colony. But nobody feels good about that. And that's the difference between the two. The sugar roll, you don't kill the bees. However, if you get a false reading or a low reading that's artificially low because you're using a method that's not reliable, you run the risk of killing that entire colony. So the expense of those 300 bees, the sacrifice of those individuals, celebrate that, give gratitude for that, but recognize that those bees are there to support and help that superorganism survive. Just one way to think about it. Let's start with the alcohol wash. So the way that you do this, the alcohol wash, you're going to take a half a cup of bees. That's around 300 bees. And you want to make sure when you are taking a sample that it is a full half cup. The worst thing that we have, and the thing that we know from research that most beginners really struggle with, is getting a full half cup. So if you end up with a small half cup, your mite count is not going to make any sense, and it could be artificially low because you have a low sample size. You need to make sure you get a full half cup of bees. The best trick I can tell you about this is use a 1 cup measuring cup, because if you're just using a half cup, you're going to have try to get this mound of bees in that half cup. It's going to be a losing battle. Get a full cup and give yourself a little bit of room so that you can get that mound of half cup of bees inside of that cup and not, crawling all over your hands and all of that stuff. All right, so you're going to collect a half cup of bees, and you're either going to use the shake method or the scoop method. Now, all of this, where you're taking your sample from, is a mixed brood frame, meaning that you want it mostly as open brood. And the reason that you want mostly open brood, meaning that it's larvae in the cells and not all capped, is because you're taking a sample from the adult bees. And so you want those phoretic mites that are on those nurse bees that have yet to go down into those cells. That's what we're trying to get, is the sample from those bees. So you're always going to be taking this from a brood frame, and you're going to be taking it from a brood frame that has mostly open brood. Okay, so that's where you're going to be selecting this from. Now, the two methods that I mentioned here, the shake or the scoop method, are two different ways of doing this. The scoop method is you're going to be using a half cup measuring cup. You're going to want to make sure it's a cup that has straight edges on it. And the scoop method basically is where you take that scoop in a frame of bees and you just run the scoop down the backs of the frame of the bees with a little bit of pressure on them, and they basically just fall back into the scoop. This is the method that I typically use. And it's a very easy method to master after you've done it a couple times. The dump method, or the shake method, is another method that you can use where you basically are going to take some sort of a container, like a white container, say like a 2-gallon paint bucket, or maybe it's a white tray or something like that. And you're going to take a frame of bees and you're going to shake those bees from that brood frame into that container that you have. When you do that, The bees that fly away are your foragers. Your nurse bees do not fly. They've never left the colony. So nurse bees do not fly. And so the bees that stay in the bucket, those are your nurse bees that you're going to take your sample from. So bees that are flying away, don't worry about them. Take your sample from the bees that are crawling around to the bottom of the bucket, and that is going to be your sample that you're going to use. But a half cup, a full half cup, more than less, right? If you've got a little rounded top on that half cup, good on you. You do not want less than a half cup. You're going to then take those into and place them into a jar. You can see this particular system I have right here. You put your bees on one side and then you fill it with alcohol. You can use rubbing alcohol, 70% or 90%, or you can use during, years ago during the pandemic, because alcohol was limited, we were using windshield wiper fluid as well. So there's different things that you can use, but alcohol, that's the namesake for this particular method. So once you add alcohol in there, you're going to shake them for a couple minutes, and then you're going to basically count the mites. Now, on this particular method that you see here, you see that this has kind of a filter in between here. So that filter allows the mites to go through, but keeps the bees back. So you end up flipping this over and counting them on the opposite side. So you'll count all the mites that come out of there, and that's how you establish how many mites per 300 bees you have, which gives you an infectivity level. And I'm going to show you a little fancy math here in just a couple slides on how to calculate that. This is by far the easiest and most accurate method. This is foolproof. You really can't screw this up unless you take bees from the wrong place in a colony. Like you took bees from a pollen frame or a honey frame or a capped brood frame or something like that. That's the only way you're going to screw this up. This is the easiest and most accurate method, which is why it is the preferred method. You want an accurate count. If you have an inaccurate count, your bees are going to pay the price. The sugar roll. Now, let's talk about why the sugar roll is problematic. Now, when I first got into beekeeping and we started, these first tests were coming out that we started using for monitoring, the sugar roll was what everybody was really excited about because you didn't kill any bees and it seemed to work pretty darn good. And so lots of organizations, including, my old employer, Michigan State University, we worked with the University of Minnesota and the University of Maryland to develop a kit even, a sugar roll kit. Well, over the years, we as researchers have begun to realize that there are some problems with the sugar roll. And here are the problems. If you live in an area that's humid, so the southern United States, if you live in a humid area and you were doing a sugar roll test, the moisture in the air cakes up the sugar and actually can give you a false reading because the sugar doesn't fully coat the bees. The way that this method works is that you coat the bees with powdered sugar, the bees heat up, the mites come off of the bees, and then they can't get back on the bees because the bees are coated in sugar, and that's how you separate the two. And then you basically shake out the mites and leave the bees in the kit. So this is a method that when you have high humidity levels, and we're typically doing this during the season, right? When you're working bees, which is the hot time of the year. High moisture in the air cakes up the powdered sugar and the mites can't get out at that point when you start shaking because the sugar's all caked up. So in high humidity levels, this does not work very well. It also doesn't work well if you don't shake it just right. This is such a problem that years ago, I believe it was a grad student at the University of Minnesota developed an app called the Mite Check app, which was literally an app that you logged into the app, you took your phone in your hand and you shook it, and the app would tell you if you were shaking at the right, hardness for Varroa mite testing. That's how much of a problem it is when it comes to shaking. If you shake not hard enough, the mites won't come out. If you shake too hard, the bees will start to let off venom, and that will cake up your sample, and you won't get an accurate sample. So it's like this Goldilocks thing. You got to have just the right shake in order to be able to get this mite sampling to work. That is a problem, especially if you're a new beekeeper and don't have a sense of how hard you can shake a bee before it sets off venom. So those are the disadvantages of this particular method. Again, if you get an inaccurate count, you run the risk of killing an entire colony. Whereas the sacrifice of 300 to save that full colony, that's the nature of bees. It's always about the superorganism. So think of it that way. The way that this works, again, you're going to take a half cup of bees. You're going to do it through a scoop or shake method, the same thing that we did with the alcohol wash. You're going to place them in the jar and powdered sugar in there, a couple tablespoons of powdered sugar. You roll the bees in the sugar for about a minute, and then you're going to place them into the shade for about 2 minutes. During that process, the bees are heating up, the mites are coming out, they're getting separated from one another, and then you shake it for 1 minute into some sort of a white container. The white container will have a kind of plethora of sugar and mites in there. Then you take some water, you dilute the sugar content so that clarifies the sugar, and then you count the number of mites that are in that sample at that point. Now, regardless of which method you're using, this is the math that goes along with it. So the number of mites that you count, you're going to divide by 300 bees. So for example, 12 mites in our sample per 300 bees, you multiply that by 100, that gives you 4% infectivity. That is the number that we use to determine what we need to do. And that changes across the season. Now, this is new. This is new information that we're always kind of revamping in the research community, but for a long time, 3% infectivity was the threshold that we used for the whole season. That's not the case anymore. So when you are in the spring, early part of the season, when bees are just getting going, there should not be a lot of mites in your colony because they've not been reproducing for the entire winter. So we use a 1% infectivity level in the spring. So if you have more than 3 mites per 300 bees, that means that you need to use a chemical intervention. You've already hit the action threshold where the bees are going to start suffering past this point. In the early part of the summer, so just as we're starting to get into summer, say late June, early July, 2% infectivity is your threshold. 6 mites per 300 bees. If you have more than that, you need to do a chemical intervention. Summer, so the height of the summer season, July, August, 3% infectivity is the level that we use for a threshold. That's 9 mites per 300 bees. And then in the fall, as we start to see bee colonies start to condense to get ready for winter, 2% is our level, which is 6 mites. This is something that you need to memorize, and this is something that should just be part of your daily routine with your bees when you're out there doing inspections every 3 to 4 weeks. These are the numbers that you need to use to determine if you need to take chemical intervention at this point. These are numbers that have been founded in research. These are not just things that somebody made up. A lot of people have spent many years developing these thresholds, and so they do work. Make them part of your daily routine when you're doing those inspections. And again, the biggest problem with getting accurate mite counts is undersampling by the beekeeper, meaning you're not getting a full half cup of bees. So always make sure that you're getting that full half cup of bees. So once you get to this point, now we need to be thinking about miticides, pesticides, okay? But first, we need to talk about pesticides. I've worked in agriculture for 30 plus years. It's what I started working in as a kid and what I still am doing today. And what I can tell you is that having worked in all sorts of different agricultural industries, everything from plant production to queen breeding to bedding plant evaluation, I've done a whole lot in the industry, both on the plant side and the insect side. And what I will tell you is out of all the industries that I've worked in, the beekeeping industry misuses pesticides more than any industry I have ever worked in, by far. And the reason is because people do not understand when they become beekeepers that they, one, are part of the agricultural community, and two, are subject to all the laws that all other farmers are subject to as well, that include the proper use of pesticides. So this slide is meant to impress upon you that you are subject to the same rules as every farmer in the United States when it comes to the use of pesticides. All pesticides used in agriculture are regulated by the Environmental Protection Agency. And these pesticides that are registered through EPA go through a long registration process. And the whole process that EPA is putting these chemicals through is to understand if they are going to, one, actually do what they say they do, but two, prevent harm to humans, animals, and our environment. And there are horror stories across human history, especially starting after World War II and the Green Revolution, horror stories of pesticides that have been used indiscriminately in agricultural systems and have had magnifying effects in our landscapes on organisms that we never even thought they would harm. DDT is a prime example. DDT was used, I mean, we would coat people in DDT back in the day. And this particular pesticide was used like it was completely harmless. And in actuality, it was having these magnifying effects all throughout the environment, infecting all sorts of vertebrate organisms that we never had intention of harming, including things like the California condor. So understanding that these laws are in place to protect us and our environment and your bees and you is really important. But you are subject to all of the laws that pertain to the pesticides you are using, those miticides that we use in beekeeping. And it is absolutely imperative that you understand that the label on that miticide, when you purchase it, the label is a legally binding document. By you purchasing that pesticide and using it, you are agreeing to using it by the labeled instructions. So at a bare minimum, every pesticide, every miticide you are using in beekeeping or any area of work you're doing in agriculture, every single label you need to read from cover to cover. And it's not like we're talking about reading a novel. Most of these labels are maybe 5 or 10 pages, but read the label. Why? Because it's a legally binding document. You are agreeing to use the product in the manner that is on the label. The label will also tell you what proper protective equipment, personal protective equipment, or PPE, you should be wearing as well to keep you safe. It will also tell you the ramifications of using these types of things outside of the parameters that they give you. So understanding that the temperature they give you, the length of time that they give you, these are how the product is supposed to be used legally. If you go outside of those things, if you're just using things in ways that it's not intended to, you run the risk of breaking the law, harming yourself, and harming your bees. So take this seriously. You are not permitted under law to apply any non-registered pesticides to an animal in agriculture, including honeybees. And by a non-registered pesticide, what I mean, if you are using any product, it doesn't matter what it is, any product to kill mites, it becomes a pesticide. I don't care if it's an essential oil. I don't care if it's something you formulated in your bathtub. I don't care if it's something you saw on YouTube. If you use it for the expressed use of killing mites, it is a pesticide by US law. And you are not allowed to use anything that is not registered by EPA. So this idea that you can put essential oils in your colony and that is an okay thing, that is an illegal use of a pesticide. If you are putting cinnamon in your inner cover with the idea that it's killing mites, you have turned cinnamon into a pesticide at that point, and it is an illegal use of that product. These things have not been evaluated by EPA. These essential oils, many of the pesticides, miticides that we have are essential oils that are derived from plants and are in very high concentrations. Many essential oils at high concentrations are highly toxic to both animals and humans. So these things just don't have any effect. You need to only use the products that are registered to be used for honeybees in the United States, not registered in other countries because those aren't legal either. And you need to be using it by the label. If it's not approved by the EPA, it is not legal to use. Period. So these are your choices. All right. When it comes to chemical intervention, these are your choices. Now, before I get started going through this, I want to note there are 3 chemistries that are not on this list that are available to purchase. One of them is Checkmite. The active ingredient is Coumaphos. Checkmite has been shown to have that mites have resistance to Checkmite. And one of the reasons is Checkmite was one of the first products we had to use against mites, and lots of people used it so much that mites developed resistance to it, and now it's pretty much useless. You can still buy it, though. Apistan, or active ingredient, is fluvalinate. is another one that has been shown through research that mites have developed resistance to. So these are two products you do not want to be using because the research has shown that mites have developed resistance. If you use them, you are going to have a subset of the mites that are in your population that are going to be resistant to this chemistry. So basically, you apply the chemical, you kill 70% of the mites, but the 30% that are left over are totally resistant to the chemical you're using, and those are the ones that are going to reproduce. And now you've got a full population of resistant mites to the chemical that you're using. So if we already have research that shows there's resistance, don't use it. The last one is amitraz. And this has been recent research that came out starting in 2020, is that we now know that amitraz, which is one of the most widely used chemicals in the commercial industry, amitraz has been shown to have mites are now developed resistance to that product. So that's Apivar. There's a new one out called Amiflex. So in my opinion, you should not be using these chemistries because we have research that supports that mites have developed resistance to these products. The products that you see listed here on this page, there has been no research that has shown resistance developed to these products yet. As soon as there is, I'm going to take it off the list. All right? But these are the ones you should be thinking about. Now, how do you decide what mite treatment you use when you get to this point? You've done all the preventative measures, you've done your mite checks, you're above threshold. What do I do now? Well, now you have to put on your thinking cap and have to make some decisions. And this is going to be different for every single person in every single location in the United States. This is all going to be dependent on where you live, what time of year it is, and what the temperature is. So let's go through a couple examples. I'm going to use myself as an example first because I live in the Upper Peninsula. During the summer, it's a very short season. We usually have about 5 months where we work bees. During the summer, it doesn't normally get above 90 degrees. Very rarely will it get above 90 degrees. So very mild temperatures. But we have a very short season, right? So we want to make sure in my situation that we're using chemistries that are fast and can tolerate, that work in our temperature range during the season. So for me, when I'm looking for a control, say in July, when it's 80 degrees outside, and I'm in the middle of the honey flow, I need to make sure I have a chemical that I'm going to be using that is quick, that can be used with honey supers on, and works in my temperature range. So if I look down this list right here, you can see that all of these chemicals will work in my temperature range. But not all of them are very fast. And because I have a short season, I need chemistries that are fast, that maybe a couple weeks at the most. I do not want to put a chemical on my colonies that takes 5 or 6 weeks to get through, because that's like a third of my season at that point. And that could be a good chunk of my honey flow. So I need something fast and quick and effective. So for me, when I'm looking at my time of the year, what I'm generally looking at are these 3 chemistries right here based on the shortness that they provide as far as a treatment. They're within my temperature range, and I can use them during the honey flow. So those are my go-tos. So that works for me. Now you'll see down here that you have some that are immediate as well. Oxalic acid is a chemistry that is very quick when it comes to activation. It actually, when you're using it as a dribble or a vapor, it is immediate as far as an action on those mites. It can also be used during the honey flow, but the caveat about OA is that it should only be used during low or broodless periods because the chemistry does not penetrate the brood cappings, which is where your mites are reproducing. So the reason that, and for me, during the mid-season, I would use formic acid products or even a hop guard is because it is going to kill the mites in the brood. It can be used during the honey flow, and it's a short treatment. Let's flip this on its end. What if you live in Phoenix, Arizona? Phoenix, Arizona, during the middle of the honeybee keeping season, or let's say during the summer, it's 120 degrees outside, and you need to get a mite treatment on. Well, let's look at our temperature range. And you'll see that none of these chemistries work at 120 degrees. And in fact, some of them, like formic acid, if you were to put that in on a triple digit day, you'll kill an entire colony. So those temperature thresholds are really important to recognize. You do not want to use these chemistries above the upper threshold. Conversely, under the bottom threshold, where you see, like, say, for example, hop guard, has a bottom level of 55 degrees. Most of these chemistries are volatile chemicals, meaning there's a temperature at which they volatilize. So if it's below the temperature, say you're thinking you're going to use Hop Guard in, let's say, November when it's cold outside. If it's below 55 degrees, the chemical will never even release from the product. So you're just throwing money away. It's not going to even come off. It's not going to volatilize at all. So these are things you need to consider. You need to consider the number of days that you have to put a treatment on, and you need to consider what the temperatures are. And you want to be in that temperature range when that chemistry is on. For those of you that live in those hot temperatures and can't get a treatment on because it's too hot, do a brood break and use the chemistries when it cools down. In those hot climates, typically you have extended seasons, so you have a longer period of time to react. But like when I lived in Southern California, like Formic Pro, well, we didn't have Formic Pro back then. It was just Mite Away Quick Strips. When we had Mite Away Quick Strips, like we would never use that during the high time of the season, the hot time of the season. It was always something that we used in the off season, well, in the cooler period. There's really no off season in Southern California beekeeping. But that's what you need to be looking at, is all of these products have their strengths and weaknesses. And you can see that some of them you can use during the honey flow and others you cannot. The ones you cannot use during the honey flow are Apiguard and Apilife Var, the Time All products. Something to consider. This is something that you all should take a screenshot, put this in your beekeeping binder, and when you do get to the point where you need to determine what chemistries you use, you pull this sheet out and you look at what your temperatures are. You'll look how many days that you think you have for a treatment. And by days, I mean good days of those temperatures in that range. If you're outside of those temperature ranges within those days of treatment, that's when things become a problem, when things stop working, especially if you're outside of the temperature range in the first few days of a treatment. So make sure you study these up and understand them. There's lots of new products always coming out, and every product has its pluses or minuses. And so you need to just kind of determine which the right one for you. And there is no one size fits all to this. This is all local. This is all based on your own region. This is all based on your temperatures. This is all based on the length of your season. So oftentimes this would be a good opportunity to maybe go to that bee club and ask folks, hey, what treatments are you using that are effective in this area? If you're unfamiliar, with your seasonality or unfamiliar with these treatment regimens. So here's an example that I put together just to kind of show you what, potentially a season-long management could look like. So in spring, you're going to set yourself up for success with a VSH queen. You may do an OA treatment before your brood comes on. Again, you like to use OA in broodless or low brood periods because it does not penetrate brood cappings. So you could use that as a treatment right before, maybe you think you might have some mites hanging around on those bees that have made it through the winter. That's a way to clean it up. When brood starts, you might want to use a softer chemical like Hop Guard 3. Hop Guard 3 is a very soft chemical on colonies, and so a lot of times when the colonies are smaller, like I'd say under 10 frames, that's a good product to use. You want to use a brood break in the spring as well. We talked about the effectiveness of using a brood break to break that brood cycle of the actual mite and of the bees so that the mites can't reproduce. In the summer to early fall, you're putting on honey typically, and so you want products that you can use with honey supers on, like a Formic Pro. You can also use something like Apiguard as well when you are outside of the honey flow. So that's something to think of as well. Oops, excuse me. So you've got that as well. So in the fall, when you go to that lower broodless period, that would be when you could do another OA application. Now with OA also, you've got different methods of doing it. You've got the dribble method, you've got the vapor method, and you've got strips now that are slow release strips. So there's 3 different methods for applying OA at this point, and all of them are going to have their pluses or minuses. But if you're doing this kind of low broodless period at the end of the season, you're typically going to be using vapor for this treatment or dribble because you want those to be immediate. This is a time of the year when you want to get in and out with your bees because we're in colder temperatures. But that's typically what you're going to use in that fall. And if you live in a cold climate like I do, usually when we do this here where I'm at, it's usually the beginning of November. It is way too cold to do a dribble application, so we always do vapor at that time of the year. So you're using these differently because like vapor doesn't impart liquid onto your bees. You don't want to get your bees wet when you're in cold temperatures, and that's so you would use the dribble during the time of the year where they can take that cold temperature on them, and that's typically, I mean, you can use that in fall. You just want to make sure that the temperatures are not, you get into real cold temperatures that can affect the bees. So that's what a season long, management program could look like. It's not very difficult to put together. And again, you're not using these chemistries, the chemicals that I have listed here, unless you're justified in using them through monitoring. So let's summarize what the rest of this whole lecture that we've talked about. What are you going to be doing for managing Varroa mites? It all starts with monitoring. This is something you're going to be doing every 3 to 4 weeks, all season long, from the moment you start working bees until the moment you put those bees to bed. This is what you're going to be focused on. This is not something you just do one part of the season. It's something you do every time you get into those bees for an inspection. Where are you going to monitor from? You're going to monitor from brood frames with mostly open brood, meaning that there's larvae in the cells, but they are not capped. How are you going to monitor? Well, you're not going to use the sugar roll test. If you're taking my advice, use the alcohol wash. And when are you going to treat? It's going to be 1 to 3% infectivity, depending on the time of the year that you're in. So remember to refer back to that and understand that during the times of the years when mites should be low, you're going to go for those low thresholds. During the middle of the season, when we have a little more cushion, that 3% infectivity level is what we're going to use. And the short version of the summary for this lecture is if you do not manage your mites, your bees will not survive. Plain and simple. There's no easy way to put that. It's just the reality of beekeeping in the modern age. It didn't used to be like this, but it is this way now. And so you as a new beekeeper, and you need to understand that this is your number one job as a beekeeper, is to make sure that these parasites on your bees are under control all season long. With that, I appreciate you being with me today. Look forward to seeing you at the next lecture. Have a good one.